In the previous lecture, we took a look at Booleans and some Boolean expressions, as well as how to do Boolean operations. In this video, let's actually go into where they're used for. So here, let's write an example program that plays rock, paper, scissors, but in the most boring way possible. It's always going to choose either rock, paper, or scissors. We'll just say it's going to choose rock. We'll do that for the starting point. And we're going to allow the user to be able to make their choice and pick rock, paper, or scissors using user input. Here, first things first, what I'm going to do, just as some common practice, is I am going to declare some constants for rock, paper, and scissors just for readability. Now, this isn't always necessary, but I think this is good for an example. I'm just going to say rock, paper, and scissors, and I'm going to set them equal to 0, 1, and 2. Now, this is sometimes known as an enumeration scheme. I'll give you a little bit of a shortcut at the end of the video for this, but it's common to assign numbers to certain choices when you do things like this. So for instance, I'm going to set rock to be choice 0, paper to be choice 1, and scissors to be choice 2. And the reason I do this is because it's very quick to check integers, and also because it's just kind of nice to read. So I could always, memorize, oh, rock equals 0 and write that in my code, and paper equals 1 and stuff like that. But if I have 20 of these, if I have something with a massive amount of choices, if you're writing a big program, then it's a good idea to do an enumeration scheme like this, where you can set each of these equal to a number, and then you'll see later when I write my code that it'll be a lot more readable than if I just throw in 0 and 1 and 2 and it's not clear what I mean. Anyways, let's move on. Let's go ahead and first things first, we're going to set what the program is always going to play. So I said let's just make it play rock. So we'll say that this is the computer choice, and I will set it equal to rock. Another thing to note is that whenever you do enumerations or constants, it's very common to do all capitals. So here I've made them all capital variable names. Here we're going to make the computer always choose rock. So computer will always choose rock. And then I'm going to read in the user input. Now I'm going to do this with characters. I'm going to make R equal rock, P equal paper, and S equal scissors, and I'm doing that partly just for the example and partly because it's nicer user input than having them do 0, 1, and 2, I think. So here, let's just print out a prompt. And we will simply enter it in from the user. Now I forgot to put namespace standard, which is why that is red. There we go. What I will do then is I'm going to create an integer for the player choice. Or actually, I suppose it would be a character here, right? We said we want it to be R, P, or S. So I'm going to make a character for the player choice, and then we will read that in. So remember, the way we do that is with cin and then player choice. So this will read one character from the user input. And just to make sure that it works, we'll simply put C out here, and we'll put you chose, and then I will put the character for now. We'll do more later. Okay, so there we have it. You chose, and then we'll put that. Let's just go ahead and run this to make sure that it works. Okay, it's running now. I'm going to go ahead and move this over. And you'll see it gets to the line where it says, please pick R, P, or S, and then it's waiting at this line for us to type something in. So now I'll simply type something in. Let's just say we pick P. And I'll say, I chose P. So that's great. It reads in from the user, but now we actually want it to be able to play rock, paper, scissors. In order to do that, we're going to need to use these things called conditionals. And what a conditional lets you do is it allows you to branch depending on the input that you get. So here, let's do different things depending on if the player chooses different options. The most simple way to do this is with the word if. So you simply put if. In C++, you have to put parentheses after that. So we'll simply put if, and then the thing that goes in the parentheses is the thing that we want to check. So remember that we went over Boolean comparisons and Boolean expressions in the last video. Whenever you do an if check, it needs to be on a Boolean expression. So the final thing that it evaluates needs to be a Boolean in some way. Now, I say that, but C++ also allows you to do this on integers. Please try not to do that. It is a little bit confusing, and I think it's not very readable to do it that way. Most other languages will just stop you from doing it. C++ just lets you go right ahead and put integers in there, and it will, I believe, do 0 is false and any positive number is true. I think negative numbers are true as well. But please try not to do that. It is allowed in C++, but it's not good for reading. Anyways, we need a Boolean expression here to check for. So let's just say we want to do the rock case. So let's say the player chose rock. What I can do is check if the player choice is equal to the character R. And then for any code you want executed after it, you'll want these curly braces kind of like you have up here for main. So simply I have curly braces here. You won't need curly braces if you're only going to write one line of code after this, but here I'm going to write multiple. Here let's just say cout you chose rock. Right, so I'm going to go ahead and just delete the one with the character now, and we'll see if this works here. Now if I go ahead and type in rock and choose that one, you'll see it says you chose rock. So rather than just printing R, it physically went here and said, okay, that matches because this is true. If we think about it, the player choice being the character R is going to then match up with that R, and it's going to go ahead and execute this code. Now let's see what happens if we don't enter R now. If I went to this and instead hit P, you'll see that nothing gets printed. And the reason that that happens is because the letter P is not equal to R, and therefore none of the code in between these braces is going to get executed. So if statements are a way to execute some code and not execute other code depending on what kind of input you have or the states of variables. Here, if we want it to do paper and scissors, let's go ahead and do that as well. So we could simply put another if statement here, player choice equals P. Then we'll want to print you chose paper. And then we'll do another one for scissors. One other thing to note just for styling is that it's considered common to tab anything whenever you go into an if. So you see this has one more space here than the code up here does. It's common to put a tab for every single block that you end up entering in, and by block I mean any of these sections with the curly braces, the left and the right. So if I was to enter another one, we would tab it one more space to the left and the right. That way it's just immediately readable. Anyways, let's go ahead and run this after I type this in. So scissors. And if we check it now and we type in something like P, you'll see it says you chose paper. And I'm not going to do it, but if we typed in S, it would say you chose scissors. So that's great. Now we have this and it's able to recognize whenever we've typed in these specific characters. And so now we could actually go and finish and tell the player if they won or they lost and not just tell them what they chose as well. So here, let's just say they chose rock. So there's two, or actually three scenarios that we could get, right? We could get if the computer chose rock, then it's a tie. If the computer chose paper, then the player lost. And if the computer chose scissors, then the player won. So let's go ahead and write that really quick. We'll say if the computer choice equals, and then this is why I did the enumeration. If they did rock, so this is a lot easier to read than if I said equals to 0, right? You can kind of easily tell just by my variable name what I mean for my code without me having to comment it. But we'll simply print cout you tied, and then an end line. And just as an example here, I'm not going to put curly braces around this. You'll see if I only write one line of code, it will only execute that line of code, and then the compiler for Visual Studio already knows that I want that, so you'd notice it tabs back to where I was. Anyways, we'll go ahead and do this with the other two choices. So if the computer chose paper, So if the computer choice equals paper, then we'll see out that you lost because paper covers rock. And then lastly, we'll want if computer choice equals scissors, then we will see out you won. Okay, so we'll go ahead and run this now. And if I was to type in R, let's just make sure we do it this way because I don't have P and S written yet. You'll see that you chose rock, and then it says you tied, which is correct because the computer chose rock. If I went up here and changed what the computer picked to, let's just say paper, then we should lose now if we pick rock because we'll be choosing rock and the computer is always going to choose paper because we're being a little bit naive with it. And it'll say you chose rock, you lost. And we see that it will only execute the code that matches whatever conditions we have. So now we have ways to only execute code that we want to be executed. That's great. Now consider that there is one problem with my program, and that is if I was to cheat a little bit and say I don't want to put R, P, or S, let's just say I want to go with K, and it does nothing. And so if we consider why that happens, if I type in K, it will fail this one. So if player choice equals R, which K does not equal R, K does not equal P, and K does not equal S, so it executes none of that code. And I probably want to let the user know that they're making a mistake by typing that in. So the way we can do that is using else and else if. So what I'm going to do here is just throw the word else in front of this and an else in front of that. What an else if will do is it will only execute the code if everything above it failed. So here, if it wanted to check the player choice equals P, it will only check that if the player choice does not equal R. Every choice above it has to fail before it gets to an else if. If I do the normal if, like I had before, it will always check it. You should try to use else ifs as much as you can if your choices are going to be discrete and completely separated or mutually exclusive, like they are here, where so if I have player choice equals R, then it can't equal P and it can't equal S, so those things can't overlap, right? I can't choose both R and P at the same time. And the reason that is it will only check this if this fails, like we said earlier. And the reason that's good is because if I have just if statements, then it's going to check it every single time if I didn't have this else if. And if I do have this else if, it will only check it if the first one fails, so it checks less often, which is why you should use else ifs as much as possible. The other reason that we're going to use it here is because we want a last condition if it doesn't match any of these. And the way we do that is simply with else. Now, else will only occur if everything above it failed. So here, else will happen if the player choice doesn't equal R, if the player choice doesn't equal P, and the player choice doesn't equal S, then else will be every other case that the computer could possibly have. So you can use it to catch every imaginable case and unimaginable, I guess, too, if you don't plan on something happening. So if I just don't see something coming, it's usually a good idea to put an else statement there because it will catch things that maybe you're not thinking that the user will do. So it's a very safe thing to do this, and you can be able to debug your programs more easily if you throw in an else and then kind of fix any issues with it later. Here, else will mean that the player didn't choose R, P, or S, so we'll simply put C out. I'm actually going to put this in braces like this for the sake of an example. I'm going to put return 0 here at the bottom. Remember, the compiler does this automatically. Main returns an integer when it finishes, basically just to tell you if it successfully ran or not. 0 means it successfully ran. What I'm going to do here is I'm going to print a 1 if the user doesn't input something correctly. That way I can let them know that they have an error with their code, or with their input, I suppose. So here we'll put C out that input is not valid, and then I will return 1. Something to know about this return that we'll get into more as we figure out what it means in terms of functions is that the program will completely stop executing whenever you do a return. Now, it does that automatically at the end of int main, I said, which is where we expect the program to end. But if I was to have more code down here between this and the return 0, that definitely will not get executed if it hits the return 1, because the return will exit whatever function it's currently in. In this case, we're in main, which is where the program starts running. So if you return from it, the program will stop running. Anyways, that should cover our error case now. So this is just a way to do some error checking. And now we know perhaps how to do this if people give us input that we don't want. So here, let's just say T, and it says the input is not valid. And you'll see that it says exited with code 1 rather than code 0, which it's been saying before. And that means that we had an error. And the reason it said that is because I returned this one here. So this would be we encountered an error. Let the user know. And there we go. We have a way to be able to do rock, paper, scissors completely. I'll maybe want to copy and paste this really quick. So let's just go ahead and change this up a little bit. So if the player chose paper, they would tie if it was paper. They would lose if the computer chose scissors, and they would win if the computer chose rock. And then we'll go down here and we'll do the last one. So if the player chooses paper, so player chooses, I'm sorry, did I say paper? I meant scissors. If the player chooses scissors, then they win if they chose, sorry, they tie if they both choose the same thing, so they choose scissors. They'll lose if the computer chose rock, and they will win if the computer chose paper. And I'm not going to go ahead and test this because it'll take a while, but hopefully you get the idea. This is how we could write rock, paper, scissors. Now let's go over a few extra things just for convenience. What I'd like to go over is one, enumeration types and how we can do those easily, and then a second alternative to if and else if. What I'm going to do is comment out our code that we just wrote, and I'll put it back when I put this on canvas. I'm just going to comment it out for now and give an alternate way to do this. So sometimes you're going to have to write out long if, else, if chains like I did here, right? Where I have if, else if, else if, else. And a quick way to do that simulates the same thing and potentially is faster depending on how the compiler implements it, as well as how many arguments you're going to have, is something called a switch. So this is basically equivalent to writing an else if. What you do is you simply type switch, and then you type the variable that you would be checking on every single time. So here you'll notice in my if and else if checks, I check on player choice every time. I check if player choice equals R, if player choice equals P, and if player choice equals S. So these all have in common that they're dependent on player choice. If I know that that's going to be the case, that's going to be the case, I can do a switch statement. So you simply type switch. Again, we need parentheses in C++, and then whatever it is that you want to be able to switch on. And then we put braces. Now the syntax for this is simply the word case and then the thing that you want it to match on. And what this needs is a break at the end of this. So let's just go through this step by step here. I'm actually going to type this all out just so we can take a look at it first. So if I do it with a switch statement, it's a little bit shorter to write, which is why I like this. You'll see that what it will do is it will take whatever you're switching on. So here I'm switching on the player choice, and it will compare it against each case. So here I will do this. It will check, is player choice equal to R? If so, it will execute everything below this label here with a colon. So it's formatted a little bit strangely. It's the word case and then a literal. It has to be a literal. In this case, by literal, I mean something that you can physically tell what it is by looking at it. So you can't do variables for cases. It has to be a constant in the traditional sense, like a math sense, which we call a literal in computer science. It just means that it's something you can physically type out, and the compiler can figure it out right there by looking at it. Literals are going to be generally like orange or greenish yellow, this color, in Visual Studio. Anyways, this will execute this code if we get to rock, this code if we get to paper, and this code to get to S. And so we want to address the else here as well, because we want a case if it fails all of these. The way that you do that with a switch statement is called default. So you simply put default and then whatever code you want. Again, I'm going to put break here. What the break does is it stops executing that code once it hits that line and then jumps out of the switch statement. So whenever it hits this break, it's going to jump all the way down here. So we'll put we end up down here after a break. If you don't put a break, then what will happen is it will actually keep executing the code even if it doesn't match the case. So if I simply put this here, then we'll see that it will execute both rock and paper. So I'm going to do that as an example. So let's just say you chose rock here. I'm really just going to copy and paste the code when I get a moment. And then I'm going to put you chose paper. And what we should see if we choose rock is that it will end up in this case, because player choice will match R. It will end up in this case. It will print you chose rock, and then because there's no break, it will keep going, and then it will print this, and then it will encounter a break and jump down here to the end of the switch statement. So another thing to note is that your code's going to start jumping around when you use else and if and conditionals like this. If something doesn't match, it's going to jump to wherever the thing is that it should jump to, depending on if it's true or not. So I said if we enter R, you'll see that it says you chose rock and you chose paper, because I didn't put a break here. Now if I do put a break here, we'll go ahead and run it again and choose rock. You'll notice that it should only print you chose rock this time, which it does. And so what happens when it executes this is it checks the player choice, which I was, in this case, the letter R is what I typed in. It says, okay, that matches this one, and it will execute all the code underneath it. So say you chose rock, and then break will tell it to jump to the very end. So this is just an alternate way to do if, else, if. Anything you can do with a switch statement, you can also do with an else, if. And it's also a little bit more convenient in C++. It is a feature I like, where you can have code pour through the labels. So if you don't put a break, it will keep executing down and jump into the next case that it has. So if I wanted to finish this program, I would simply take all of this code here and basically just copy and paste it into where it belongs for this. I guess another thing is I don't need the braces around any of this, so we'll simply do it that way. You could also do a switch statement inside this switch statement that checked for rock, paper, and scissors. So here if I said switch, and then I switched, if you notice, these all have in common computer choice, right? They check the computer choice if it's equal to rock, paper, or scissors. I could say case rock, and then this line of code. I'm going to tap this, and then again I want to break. So case paper, break, and case scissors, and break. I'm just going to take this out of here, and I'm going to put it into here. Another thing I think I did without mentioning the fact that I was doing it was that I've been nesting these conditionals. We'll look at that up here. So it is totally fine to put if statements inside of if statements. Consider whenever you have these curly braces that anything inside of it is it's kind of like its own self-contained code. It will execute on its own, and you can write any what's called a sub-program inside of it, basically its own self-contained program within those braces. So here I have an if statement that only gets executed if this if statement passes. And the reason I say that is because the same thing happens here in this switch statement. This switch statement here will only get executed if this case passes. Anyways, I'll finish typing this all off camera and post the example onto Canvas. I think there are only two other things I want to mention. I'm going to go ahead and comment this out, and we'll go back to using the other one. Right, so let's go ahead and uncomment this. One thing I want to just mention is some rules regarding variables when you use them with if statements. So we have something called scope, which I'll talk about in a future video in more detail, but the idea is that some variables have scopes and they die when they leave that scope. So far from what we've been writing, we only have really had a global scope and a main scope, where these are all global, which means they exist for the duration of the program wherever you go. And things like this, where I do the variable declaration in main, are going to, oh, and I should probably change this to paper. Things that are here in main are only going to exist as long as main is running. So if we go anywhere else, which you'll see that we can do that with code in the future, then we don't have access to these variables anymore. Now the same thing happens if you do variable declarations inside of if statements. So if I was to create a variable called int x, which is a new variable, and I set it equal to 3, then it's totally fine for me to use this variable anywhere inside of this if statement. So its scope is basically the containing block, this thing with the curly braces that it was declared in. So this x will exist from this line, because that's where it's created, until it hits the next brace that it is going to be contained within. Which means if I went down here, and let's just say this is outside of the if statements, if I was to go down here and try to see out x, what you'll see happens is that it gives me a compiler error. And it says undefined. And the reason that is because x is going to die as soon as it hits here. Any variables you create inside of an if statement only last to the end of that specific block of the if statement, which also means I can't use x in the paper case or the scissors case if I make it in rock. So something very important to consider is that the variables will delete themselves if you declare them inside an if statement. So make sure if you're intending for a variable to be used across multiple ifs or else ifs that you declare it before the if else if and not just in the if scope, because it will just delete it. Okay, last thing I want to mention, which is not something that is 100% necessary, but I think it's very convenient and I like to teach it, is that we can do an enumeration type like we did with these rock, paper, scissors and have the compiler automatically generate it. So here I thought a common sense way to do rock, paper, and scissors was to set rock equal to 0, paper equal to 1, and scissors equal to 2, because that just counts upwards. If you have a scenario where this makes sense, where you think, oh, I could do this as a number and I want it to be more readable, you can use what's called an enumeration type. And the way you do that in C++, and I think most languages, is you simply use the word enum, and then you give a name for the enum. Here I will say RPS, let's just say for rock, paper, scissors, and then you put braces, and then you give the name of the enumerations you want. So here I'll type rock, paper, and scissors. And I'll simply comment this out because we have it declared twice now. And you'll see if I scroll over it in Visual Studio, it says rock is equal to 0, paper is equal to 1, and scissors equal to 2, which means that it automatically generates this code that I just wrote for me, which is great. It also makes them constants. So if you don't want to have to type all that stuff out every single time, an enumeration type is very helpful. And you'll notice that it really didn't do much to my code either, right? These just happen to be here and it still works, so it just fills it in for you. So an enumeration type is just a shortcutted way of quickly numbering things. So you can use this for choices in like a game, or if you have a user interface where you think that there are going to be multiple choices, that's helpful. Or you can use it for something like days of the week is what I would say would be a common example, where Sunday is 0 and Monday is 1 and Tuesday is 2 and Wednesday is 3. It's really just a convenient way to be able to number things quickly. Anyways, I think that's about all I wanted to say, and we'll take a look at some more interesting things with Booleans, and we'll probably do an example after this one.